Hey, YouTube, how is it going? I hope all is well. Today we're going to do kind of a quick run through of the Fender Champ Model 5F1, and we're going to compare it to my build, the Champers, kind of talk about the differences and what you can do and where, and just kind of some of the design challenges that I was faced with in order to make the my amp, right? So let's just get on with it. So we're going to kind of try to move pretty quick, but I'm going to try to give you literally a circuit rundown and explain some things as to why you would do what. So anyway, Fender input, standard for pretty much all of them, 68K, 1 meg. That's the thing. That's the good values to go with any and every time if you're going to do a 2-input, or a high-low input. Objectively, you want to get this guy on the grid of the tube, especially in V1A, or the very first preamp tube. Again, as mentioned before, that is to keep the Radio Disney off of your, from being amplified through your amplifier. So that's the idea behind that. I went with 22K, and then I put a 10K directly on the pin of the tube. The idea behind that was to have a little less resistance on the input side, making it just a little bit brighter. So effectively I had 22, put that in half, you got 11, plus in line with 10, you end up with about 22 or 21 or something like that. Whereas in the low mode, you end up with the full 22 with the 10K, so you end up with something like, the 32 or some odd K. So you still get a little bit lower volume and all that jazz. It's just a little bit darker, not much. So that's what I did differently there. Now, moving on. I did everything exactly the same for this position here of V1A. I went with a 25 UF bypass cap, 1.5K, 1500 ohm if you will. Ooh, excuse me. My apologies. How rude. Sorry, just been drinking a Dr. Pepper, so it's coming back to bite me. Anyway, my apologies. So 1500 ohm cathode resistor, 100K plate. I went with that. Great values. I like those. So that's that. Now, in a Champ, this guy right here is the problem for most people with how the amp kind of sounds farty or blatty or just otherwise kind of, just farty, I guess is really kind of the word for it. It's just a really big value to have when you're fully bypassing the first stage. That's really all it is. So most people here will shrink that down by half or more in order to help reel in the amount of bass that this stage here is amplifying, which just helps keep this guy out of being farty and, blatty. I went with a 0.0047. So I went with about 1/4 of the size, and that helps a lot. It tends this amp more towards lead friendly territory. So that's that. Now, something else I did was I put a grid stopper in this position right here. So from this point to this point, I put a 220K in line. It does act a little bit differently than it does if it were on this side of this volume pot, but it is subtle, not much different. I did that for two reasons. One, I kind of wanted to have it there for tonal purposes. If I needed it or not, I could always eliminate it, but it offered up some tonal variation for me. One is to control the highs and or add highs back if I wanted to. So you can go larger here. So if I went with 470, let's say, it would darken it up a little bit more. But if I put a cap over the top of it, I could also then brighten it up even more if I wanted. So it gave me tonal variation. So that's why I did that. Everything on this channel or this second gain stage here is exactly the same as the first stage. I put a 25 UF bypass cap around the 1.5K cathode resistor and 100K plate. All that does is make this stage here in this particular design just a little bit more amplitude, more volume, and it has a little more bass. That's really all it does. So it's just a little bit more of everything, if you will, than it does in this, configuration here. That's it. Now, for the coupling cap, I went with the same value. I've mentioned it before. 0.02 or 0.022 is like the perfect value to start with in this position on any amp build. If you're not sure where to go, start there. If you need more, go bigger. If you need less, go smaller. I doubt you're going to need much less, but 0.022, 0.01, 0.047, and 0.1 are kind of that's the range that you're going to see there. 0.02 is kind of the number one value, I would say. So there's that. Now, there are a couple things that we need to talk about for the power tube. There are two different topologies for a power tube and how it is biased. There's cathode biased and there's fixed bias. Cathode biased is done via a cathode resistor from the cathode to ground in between the power tube's cathode to ground. So that uses the cathode of the tube to actually set a bias for the amp. A fixed bias amp injects the bias voltage directly into the grid leak of that tube stage. So the cathode is tied directly to ground, and then a negative voltage is applied here in order to get the bias to do what it needs to do. So that's the differences between those two topologies. And because of that, there is a difference in what you can have from grid to ground reference. So when I say grid to ground reference, I am literally talking about the grid here and its reference to ground via the grid leak. This also includes any grid stoppers. So another resistor in this place here is included in that value. Now, the reason I make a point of this is that there are two different values or maximums, if you will, dependent upon the type of topology that you use. In a cathode bias amp with the 6V6 GT, the maximum grid to ground reference voltage or impedance that you can have is 500 kiloohms. In fixed bias mode, that's almost half at 300 kiloohms. So that's why it's important, and that is generally why the value that you see for the grid leaks in most all amps generally isn't much larger than 220. EL84s are a different example. You'll see them with 100Ks, or 470Ks, excuse me. But generally, you're going to see 220 or lower in this position. But I ended up going with 150K in this position. Two reasons. One, I had more than enough voltage to throw away before hitting the power tube, so I had more gain than I needed. And two was I used a higher than normal grid stopper on the 6V6 power tube. There's no limit to how high you can go so long as you don't break that grid to ground impedance reference voltage or reference value I was talking about. So I went with 100K and 150K, which means I had about 250K of grid to ground reference. That's what that was for. Now, why did I go with a higher value here? To help tame the highs a little bit. I had just enough highs on the top that I wanted to get out of the amp. And this is a good late stage tone option that you can go with by using a grid stopper. You can do it on these guys as well, but doing it here, it's very subtle. It takes a pretty large value for it to start making a difference. But that kind of helps you understand why most amps use a 1.5K to a 5.6K grid stopper in this position here. They're not really using it for tonal. It's advisable to have one, regardless of whether or not you need it, but it's, a 1.5K is just enough to make sure that this tube doesn't self-oscillate. It can do that, and it is more prevalent when you start adding negative feedback, which let's talk about now. So I did end up going with negative feedback. I initially tried the amp without it, and it was just a little too rowdy. There was a lot more distortion, of course, because it's uncontrolled, but there was also more highs and a bit too much woolliness in the lows. It was just too out of control. So I went ahead and injected it just like they did here with this same value there. And it was like, okay, yeah, I like that. This works. I went off the 4 ohm tap of the transformer that I used. I went with a 4/816 ohm output transformer. So it's different than the stock options that come on 5F1s and the Champion 600. So that allowed me some options. I tried it on the 8 ohm. 8 ohm reeled it in way too much. And for S's and G's, for those of you not knowing of what that means, this means shits and giggles. But I also tried it on the 16 ohm for S's and G's, and it was way too much. Yeah, I mean, it made it so this stage here almost couldn't distort with the amount of gain I was pushing through it, and or to it, I should say, and it was just way too neutered. So I put it back on the 4 ohm. Gotta say it, Fender nailed it with this, this design right here. Perfect. Do be mindful. There are different ways to inject the negative feedback. If you look at the Champion 600 schematic, they had a voltage divider, and it just changes how it gets in there. It can, that's all it does, is it just changes how much of this gets into this cathode. That's it. So there's a couple different ways you can inject that, but I went with this orientation here. I think it was spot on. As for the power tube and how it ended up being biased, I ended up going with a 100 UF bypass cap, which doesn't affect bias, by the way. It's just, it changes how the tube amplifies. That's about it. So a little more lows. That's about it. And I went with a 400, or not a 470. I started with a 470 and ended up with a 510 ohm. With the voltages that we were working with and how I wanted to bias the guy, a 510 got me right to 95%. So spot on where I would like to have it running at. And that got me there. So now let's talk about the power supply. There was a couple people that kind of teased that my amp was just a Fender Champ with solid state rectification. I think I've kind of already showed that's not exactly true. I've changed enough things to go on to kind of fundamentally take it away from the Champ, topology, if you will. Having extra grid stoppers, having the bypass cap here, changing a bunch of other values and this, that, and the other, really kind of changes this amp fundamentally. And something else I did was in the power supply, which also changes it quite fundamentally. Aside from just going from tube to solid state. So they're using a slightly higher output power transformer. So they got a little bit more voltage at the B+1 node, even after going through the rectifier. The rectifier tubes generally do drop some amount of voltage. It varies depending on the different tube types there are, but in this case here with the 5i3, they end up with about 360 volts at the first stage, or at the first node, I should say. As you may recall, we ended up at 350. 10 volt difference. That's not unheard of. It's not a crazy amount, to be honest. But they went with a much, much larger dropping resistor. 10K. 10K is pretty big. In this case, it's enough to drop 35 volts between these two nodes. I went with a 2K, which only dropped us about something like 8 volts or something at this point here. I have another 1K grid or screen grid resistor here, which helped drop another couple volts or whatnot. But in either case, so we went from 348 on the actual plate to 342 on the actual screen, which, is a difference of 6 to 8 volts or something like that. And I mentioned in the video that you want to have the screen at least a little bit lower than the plate, preferably more than 10 volts and right around 20 to 25 volts, I think is kind of the magic number. Much beyond 30 volts, I think is a little extreme. In this case, they have a 35 volt difference between the plate and the screen. I think it's a little bit much myself, but I can't really argue with the fact that the Fender Champ 5F1 is like the champ of all champs. So this is a very much loved amplifier by many, many, many different types of players. So I can't really say anything to that, it's just a personal opinion, I guess, if you will. So I went with a 2K. Now, pay attention here. 16 UF. There is a limit to how big you can go with these values here when you're using rectifier tubes. In my case, we're using solid state rectification, so there is no limit to how big you can go there. I would say with any given rectifier tube that you're going to end up utilizing, 47 UF is probably the biggest you can get away with. I would say that 30 to 33 UF is more than likely the safest number to choose if you had to just pick one and be done. In either case, even with a 30 UF, it's still double the value that they went with here. So I went with 47, not to just go crazy, but just because it's not an extreme number and it's still safe with all the other versions of different rectifier tubes that I use. So I've already got 3x the amount of filtering at this point here. Now, filtering just gets the ripple off the HT line. And if you can imagine this guy here, this resistor, that symbol, see how it kind of zigzags up and down? Let's just imagine that's what ripple looks like laying on this HT line. The larger that you go with and the larger you go with here in these two values, the more flat line you're going to get. So there is a calculator online that you can use to factor what the amount of dB loss, I'm using my quotation fingers, but they measure the reduction in ripple by dB. So in either case, moving on, it's not the most important thing. As long as you go with, values similar, you're going to be okay. So I went with a 2K here, and at this node, I went with a 30 UF. So again, another threefold amount, if not more, of filtering at this point. So I'm not worried about ripple at this point anymore. There you have it. Now, I went with the 10K at this point here, and I had mentioned before that part of the determination in values between these is deciding how much voltage you want down the line. So I wanted to maintain some voltage further on down the line, and I was willing to give up a little bit at the screen grid. So I went with 2K in this position. Obviously, 10K is pretty large, I feel, for this spot here. The larger you go in value, the more sag that resistor will have on the remainder of the amp. So you kind of want to keep that in mind. This value here is usually 1K to... it's usually pretty low, usually not much more than 2K, but some amps obviously go larger. But moving on, I went with a 10K in this position here, and that allowed us to have 318 volts at this point here. A good number, that's what I was looking for, that's what we got. And at this node, with the filter cap, I went with 22 UF, so still almost 3x the amount. So all in all, I have almost 10x the amount of ripple control on my amp as does the Champ, which changes again fundamentally how this amp is going to react and respond. What are those differences? Generally speaking, the more filtering that you have, the firmer the HT will be, which means it will be seemingly more bass, and it's not that there's actually more bass being amplified, it's that the HT rail can keep up with the power needs of amplifying that bass, so it just appears that there's more. There actually isn't. The same amount is going through, it's just you can actually hear it because the amplifier is more accurately able to reproduce it. Secondarily, it does help with some of the abruptness or attitude, if you will, of the power supply. So having a very firm power supply can really make sure that these guys here are doing what their job is in a linear fashion. So if you really spank the front end, the power supply is going to allow you to spank that energy through. Whereas if you go lower in filtering and you have a pretty weak power supply, you get what they call sag. And that sag is literally the HT dropping in voltage in relation to the input. So you hit a really hard thing and it's, initial attack might be there, but then the power supply runs out of the energy to keep up with it and the amp kind of self-compresses. And if you have too low, if you go extremely on the low end, you can actually get ghosting. So in amps where ghosting is prevalent, I think the JTM 45 is kind of one is noted for that. You can hear it just kind of like a modulation that's kind of hidden just underneath the note that you're playing. And it's literally that the HT supply has ran out of enough energy to keep up with things that you can start to hear the ripple manifest itself back into the signal chain and it amplifies it out. So it's just it's literally a ripple getting past past your plate resistors and being injected into the actual signal flow of the amp. So that's what ghosting kind of is. So I'm not saying going larger is the best thing. Going just the right amount can actually give you a nice kind of bloom. It can kind of give that amp that feel, and it's a feel thing. So too much of a good thing is still too much, but you still have to, play to a minimum, if you will. So those are the major differences between the Fender Champ and my amp. Fundamentally different, even though they use a fairly similar topology. So let's move on and check out some pictures. So this is before I had actually finished building the amp. I still have the 470 ohm. I ended up going with a 510. I would never in a million years let my amp go out with a hook like that on that. This would have been cleaned up to look very like a natural flow. As I mentioned, I ended up going with a grid stopper here, but, and this ended up laying down. You'll see that in another thing. And you can see here, I hadn't even changed out this value here yet. So this is in the testing stages. This is probably right about the time I handed it off to my client the first time for him to kind of check it out and see if we were even going in the right direction at all. He was quite smitten with it. He told me not to change anything, but I kind of felt we could still do better. And that's where we get into some of the changes that I made. So let's check those out. But first, let's actually look at the layout that I did. So as you may recall, in the first amp, or the first series of this, I had all these in a line here, and I had a slightly different layout. I was trying to get this guy to kind of fit somewhere in here or something like that, and it just wasn't going to work. I didn't have enough space over here. I had to end up actually putting the turret over the turret board over the top of this tube here. The inputs went up like right up against this guy right here, so I was just out of space, so I had to conform to this. I ended up with a chassis mount right here and another one like right here. So that also forced me to kind of change the size down a little bit. Sorry, there's still some typos in here, mess ups or whatever. This is a true value. This one is 33 UF. It's actually a 30 in this position. This one actually is a 22, but I didn't resize this cap. 22 UF in this position is about 2/3 the size of this guy. But everything else is pretty much correct. So I got the 510 that I actually ended up with, the 150 here, the 1515. These two are identical right here. And then this guy here, this is the one I was talking about where it was, for tonal possibilities. And the nice thing about it is that even if I didn't need it or didn't want it, it only cost me one turret to find out. So there you have it. This is how my actual layout ended up going. It changed quite a bit from the last one. So that's kind of the downsides to working within the confines that you had. I have 5.5 inches, and this all fit within 5.5 inches. Going with it like this, made it just symmetrical. It was just kind of, it worked that way. So why not, right? Let's look at that guy. So So this is another view. This is closer to being finished. You just kind of see how things were done up in here. You can see the chassis ground there for the power. You can see how this laid out here. I can tell you right now that this guy got pushed down just a little bit to clear this, and this got pushed up or pulled up a little bit to clear that. Obviously, I didn't leave it where they were touching each other like that. That would be ungood. You can see the feedback resistor there, the negative feedback. You can see there. I try to make it so you can always see the values from the top side. So I got my 100K. Let's go. So this is just another view kind of that same point in the build. You can see here that I ended up having to push this down to make sure I could clear the top of the chassis. I still hadn't changed that out yet, but you can see here I went with the 150K, 220. I like to make it so you can see all the values of everything. So That is just a me thing. You can see I did glue these guys down. It's always a good idea to glue those guys down. You don't want them flapping in the breeze. So there you have it. There's not much to it. So let's go to this guy. That is just kind of how I ended up doing it. The output transformer ended up over here, and I ran some of the wires down that way, and I just ended up running those down and around this way. I didn't really want to try to run everything along the backside there like that and try to make it all squeeze in there. And this was far enough away from everything and didn't eat up too much length. So I had to make a decision, and that's what I ended up going with. So that's what I went with. But I hope this answers a bunch of questions. Oh, you can kind of see here the 2 chassis points. So that's part of the reason I had to go with a 22 UF. And you can see it's quite a bit smaller. But I hope this answers a lot of questions. I hope I gave you some ideas and inspired you. I thank you for sticking with me this long if you have. But just thank you, and we'll see you on the next one. Take care. Goodbye.